As you can see, today's topic is gas fuel injection, the program that we have for gas fuel injection. And let me start by saying thank you all for being here. I know it's a lot to get away from the counter, get away from the field, get away from those conversations you're already having with your customers. But after this, we're hoping that you'll be able to go and have even more conversations and more thorough conversations about why the gas fuel injection program at Standard is what they should be looking at whenever they need injectors or anything really fuel related. So again, thank you for being here. And this is going to be I think some great information to go out into the field with and really drive some sales. Again, gas fuel injection. And we're going to talk about the different types of fuel injection systems. We're going to talk about why fuel injectors fail. We're going to go over a few technical tips that I think will be helpful, especially if you have a DIY customer that's working on a vehicle or maybe a new technician in the shop that hasn't run into some of these things before. And then we're going to pass it over and talk about some really important testing that's been done to show you exactly why the standard gas fuel injection program is the program that you want to be talking about. We're going to talk about remanufactured injectors, or as you see in their quotations, remanufactured injectors, because there is a myth to those that I think you're going to be surprised by. And then we're going to talk about the competitive landscape, how we stack up and how you stack up to your competition as a result of the program, and then the sales support that follows behind the program to make sure that, you're taken care of and your customers are taken care of. So that's the topic. That's the agenda there. And so we'll start by just talking about real quick, what do the fuel injectors affect? What systems are all affected by the fuel injectors? Well, obviously, poor fuel atomization is going to reduce engine performance. We have to have the right amount of atomization, the right flow rate, the right spray patterns. Everything has to be perfectly in sync for the engine performance to be the way that it was designed to be. We also have to factor in fuel mileage. And so anything we have with an incorrect fuel flow rate can drastically impact our fuel mileage. Whether it's, creating a situation where we use too much fuel or again, where we're not using the right amount of fuel on the bank, either one is going to decrease our fuel mileage. We also have to be mindful of engine reliability. So remember, with a wide or an incorrect spray pattern of an injector, it can wash away oil from the cylinder walls, which we definitely don't want because we don't want to burn those pistons up. And so engine reliability is a big deal when it comes to fuel injectors. And then, of course, emissions. Incorrect flow rates again, and unburnt fuel going through the system is going to have a very harmful impact on emissions components. And I think we all know that, but we've seen it in different ways. It can, maybe mess up the catalytic converter, maybe mess up the O2 sensors. There's a lot of different emissions components that can be affected by poor, running fuel injectors or fuel injectors that are not running it at all. So that's what they affect. Obviously, we want the combustion event, so that's what's going to happen. But when we have bad fuel injectors, we can have a lot of impact and damage to the engine and the components behind it. So when we look at gas fuel injection types, now remember, obviously there's carburetors and there's still TBI, and you'll see some of that, on the TBI coming up, the throttle body injected injectors. But primarily, we're going to be talking about multi-port fuel injection and gasoline direct injection. And now with multi-port, obviously there's lower pressure, it's pulse width controlled. And on port style injection, which still is the vast majority of vehicles that are on the road today, and that style of injection, it's going to spray the fuel into the intake manifold itself. And then when the intake valve opens, it's going to draw in the air. It's going to mix with that fuel, and it's going to create the atomization needed going into the combustion chamber. And then with the port style injector, it's going to be about, give or take 50, 60 PSI. That's a pretty good range, right? So it's a pretty low pressure. Now, what's going to happen is the intake manifold is going to be under vacuum. And so there's going to be maybe 25 to 30 inches of vacuum, say at idle. And then as the throttle is opened, as the driver gives the command to the accelerator pedal, the vacuum is going to drop. And this is especially true in these newer turbocharged vehicles. And so now we're going to have the correct pressure that we need. And so in order to compensate for that changing environment with the pressure changing at the tip of the injector, there's going to be a fuel rail or a fuel pressure, like a fuel pressure regulator that's going to compensate for the atmospheric pressure change and increase the rail pressure, allowing it to spray more fuel into the intake manifold. And once that happens, it's going to open up, it's going to send that air and that fuel into the combustion chamber. It's going to meet that spark, and then we're going to have our combustion event. Now, on the right-hand side, it looks a little different, right? So we're now leading the way and moving into gasoline direct injection. And as the technologies have advanced, things have changed a little bit. So instead of being port injected, where we're injecting into the manifold, we're going to directly inject into the combustion chamber. That's where the GDI injector is going to be located. So in this style, we're not actually going to mix the air and the fuel in the intake anymore. We're simply drawing air in through the intake, and then the fuel is being directly injected into the combustion chamber. So rather than being delivered into, say, like that negative 30 inches of pressure like we see on port injection, it's now going to be injecting up to a few thousand psi of combustion pressure. And this requires the fuel to be at a much higher pressure. So in these systems, we're going to see anywhere between 2 and 3,000 psi. Very high pressure instead of that low pressure system. But again, this is being directly injected into the cylinder, much like a diesel. So we got to be careful in these applications. The spray pattern is very significant. It's actually going to direct how it's burned and how it could affect the oiling on the vehicle and certainly affect the piston. And so really the long-term longevity of the engine is at stake here. And so again, just a simple recap with port injection, we're going to mix the air and fuel first, and then we're going to send it into the combustion chamber to meet the spark for the combustion event. Whereas gasoline direct injection, we're going to directly inject it into the cylinder. And so that's really the simplicity of the system. There's more to it, but that's how they're installed on the head, and that's how they send the fuel into the system. Now, with GDI pretty much leading the way now as far as the technology that's being used on modern vehicles, we'll kind of put the whole system together here because you're going to be getting a lot more conversations and calls about GDI today than you have in the past. You're still going to get plenty of calls, about your multi-port injection, but with GDI increasing the way that it has, this is going to be important to know. So if we look, it's going to start on the GDI system up in the upper left-hand corner. We've got the fuel pump in the tank. And we're just going to refer to that as the low pressure, fuel system. Again, very much like a diesel. And this is going to be about 40 to 80 psi, and it's going to supply pressure up to the GDI pump itself. And then the GDI pump will be mechanically driven off of the camshaft, and that's going to actually create thousands of different psi's of pressure. Again, anywhere between 2,000 to 3,000 or so. And that fuel is then going to flow through some rigid metal lines directly to the fuel rail where it can be injected directly into the cylinder. And if you look on the right-hand side there, this was at an auto show. Unfortunately, with the lights, it's kind of shiny there, but you can see the pump installed. And then that shiny component in the picture is the cam follower. So that's actually pressed against the spring of the GDI pump, and it's being phased by the cam lobe on the camshaft. So these are, again, cam-driven GDI pumps, and that's what's going to help create that high pressure that we normally wouldn't see on a multi-port injection system. So again, multi-port's what's really on the vast majority of vehicles still today, but now we've seen a major increase in GDI vehicles on the road. But what else can they do? Well, how about we do both of them at the same time? So one of the problems with GDI is that there's a lot of carbon buildup that can happen. And so when that happens, it's going to mess with the spray pattern, and that's what's going to have an impact on the cylinder walls. And again, we don't want to, clean the oil off the cylinder walls. We want to protect those pistons. And so how can we clean those? I say, how can we clean them? How can we help clean those GDI injectors, but also help with fuel economy at the same time? Well, in a lot of applications now, they're actually going to dual fuel injection systems where these vehicles could have 16 fuel injectors. They'll have, let's say it's a V8 like the 5-liter Ford, you'll have 8 multi-port injectors and you'll have 8 GDI injectors. Now, the way it's going to work is when you're at low RPM, say at idle or just cruising down the road around 30, 40 miles an hour, that multi-port injection system is going to be utilized by the computer so that we can get better fuel economy because we're not demanding as much power. However, when we do hit the gas pedal and we need that more power, they'll switch to the GDI system where we're directly injecting and getting quicker response, more power, and more fuel. At the same time, whenever the multi-port injectors are being ran, they're actually going to help clean the tips of the GDI injector. So they're working really in tandem. We've got better fuel economy with multi-port, and we have better power and response out of GDI, and they're working together to give the driver the response that it wants, that it's asking for whenever it hits the gas pedal. And as a byproduct, we're trying to help clean those GDI injectors at the same time. So this is important to note. If you have a technician call or a customer come in who's looking for an injector for their vehicle, and you look up the vehicle and it shows both multi-port and GDI, it's not a mistake. It's not that you have to pick between the two. It's that you need to know which one has failed or which one is being replaced, because in some cases, again, you may need upwards of 12 to 16 fuel injectors depending on the size of the motor. So make sure you look at that when you have a customer come in. Again, it's not a mistake on the screen. It means that they probably have both in the vehicle. So again, we're still going to use multi-port, we're still going to use GDI, and now we're going to see vehicles using both. So neither one are going away anytime soon. Now, let's talk about what happens when either of these systems fail. And this is going to be true on GDI and multi-port. So when an injector fails, the problem is the ECU doesn't know which one failed. Now, hopefully in the near future, there may be a sensor for each bank so that the PCM can actually determine which one has failed. But at the moment, all it knows is that the bank is not performing the way that it should. And so as you see on the screen here, if you look at the bottom, you see the four cylinders on the bottom side. We have the four blue stars, and those are the injectors doing what they're supposed to be doing. They're even. They're not one bigger than the other because the bank is getting adequate flow to each injector, and the injector is flowing like it should. And so each bank is getting the right amount of fuel and air and combustion going on. But if we look at the top, we see we have a dead cylinder here. We don't have an injector firing at all. And again, the ECU does not know which one it is. All it knows is the bank pressure went down. So what the ECU is going to do at that point is it's going to command the injector to go and turn on longer because it wants to build that pressure. And so what's going to happen is if we don't have one of these cylinders firing at all, we're going to command more pulse width heading to the injector, and then that's going to turn the injectors on longer. But now we're going to be overfueling three cylinders because we have one bank that's not, or one cylinder that's not firing at all. And so what that's going to do is create a whole bunch of scenarios that we don't want. One, we're going to have too much fuel going into the combustion chamber that's going unburnt, which again means we could wash the walls of the cylinder and, basically make a situation where the piston is not lubricated properly. But we're also going to be sending that unburnt fuel straight out of the exhaust. And when that happens, that's when we start seeing O2 sensors getting damaged. We start seeing catalytic converters getting damaged, and a whole host of other things that can go wrong. And so again, unfortunately, we can't tell which one it is. We're going to have to do a diagnostic to determine which injector has gone bad so that we can get this bank sorted out. So it's important to note when we have an injector fail, we could run lean, we could run rich, or we could do both, because in this situation, the ECU is going to notice that the bank is running lean because we don't have one of the injectors running. So it's going to command them on longer. And now we're going to have three injectors running rich, and it's not going to balance out. It's going to end up sending unburnt fuel. So we don't want that. So we definitely want to make sure when an injector fails, we go in and do a diagnostic to figure out which one so we can get the system back in order before we damage a lot of other components. Now, that's when they fail, but what causes them to fail? Well, there's a whole host of things, but the most common are going to be electrical problems. Again, these are subjected to repeated heat cycles, a lot of vibration, especially with these newer engines, a lot of extra vibration that's going to cause the the electrical components to fail. We can also have contaminated fuel, which is very common, unfortunately. Depends on what gas station you go to, whether or not their tanks are clean, whether there's debris in there. It really only takes, and Aaron's going to talk here in just a little bit about a specific component within the injector that it really only takes about a grain of sand to completely clog up. If that happens, we're going to have a situation where the spray pattern is going to be wrong. We're going to have a situation where the flow rate is going to be wrong. And again, we don't want that wall washing and we don't want that rich or lean situation going on in the cylinder. And then we also have the carbon buildup I talked about with the GDI. Now, the carbon deposits form right there on the injector tip, and it's going to affect the atomization of the fuel coming out. It's also going to make it to where the spray pattern is messed up, the flow rate's messed up, and it could clog it up completely. So in those situations where we have both multi-port injection and GDI, this is actually going to help with that carbon buildup and try to clean some of that off. Unfortunately, if it's just a standard GDI, setup, it's only going to have the GDI injectors, and it's going to be very easy for that carbon to build up on it. And then obviously leaking injectors. Any seal can cause, failing can cause too much fuel to enter the cylinder. And that's going to, again, damage the engine and emissions components. So we got to be careful about, sealing properly, especially when we replace one injector. And that happens very often where someone has a bank of four, or maybe it's just an inline four cylinder and you have the four injectors and we only replace one. Well, when you pull that rail, you're going to be pulling all the injectors usually, and you need to replace the seals on it. That way, when we put everything back together, everything's sealed properly. If we only replace one injector, but we don't replace the seals on the other three or six or whatever it is, there's a very high potential of those leaking after the fact, and that's going to basically void the job that we just did. So always make sure we replace seals, but this is the most common reasons why the fuel injectors fail. So with that, let's talk about a couple of quick tech tips. So again, if possible, and we know that the customers vote with their wallets, we do understand that. But if you have the ability and the customer can agree to it, it's always a good idea to replace fuel injectors in matched sets, right? But again, they don't fail limited to say a single injector. Let's say debris got in there, one injector failed, it doesn't mean there's not debris in the others. They just haven't failed yet, right? And keep in mind, old worn injectors, it might cancel out the performance of the new injector. It's very similar to that of ignition coils. You have, an ignition coil with 150,000 miles or a fuel injector with 150,000 miles. How much longer are those others going to last and perform like they did brand new versus that one that you replaced? So if we can get the customer's commitment, it's always a good idea to at least do a match set on a bank. Now, say it's a 6-cylinder and you're only replacing one or two on one bank, just do that one bank. Doesn't necessarily mean you have to do both banks, but once you're on a bank, it's a good idea to do those matched sets, at least on that bank. Now, another tech tip here is with GDI, and you'll see this is one of the reasons there are kits available now. With GDI systems, a lot of the components are one-time use only. So the bolts, for sure, you have to throw those away. On the high pressure fuel line, you're going to notice when you take the old ones off and you look at a box with a new one in it, they both have a yellow tag on them. That yellow tag is letting that technician or that customer know, hey, don't reuse this. You have to throw this away. And it's because they're a torque to yield bolt, and the same thing with the high pressure fuel line. It actually changes the shape of the seating whenever they're installed. So once you remove them, you're never going to get that seat back. So that's why they are required to be replaced. So if you do have a customer, or again, a technician that's working on a GDI pump, or they're removing a GDI system so they can replace an injector, these still have to be replaced. Remember, even if they're going in to remove just one injector, it's very common that they're going to have to remove at least the fuel lines. And when they do that, they're going to have to replace those at the same time as the injector. Now, the cam follower is not a mandatory replacement. However, this is what's being driven off the cam and plunging that spring so that the GDI pump can build that high pressure. If you're already tearing this thing apart, and you know the pump is good, you're going to reuse the pump, that's fine, but you got to replace the lines and the bolts anyway. You're already in there. You may as well just throw a new cam follower in. That way we have adequate pressure being built. So that's very important to note, especially when you have customers that are not very versed or familiar with GDI. And then remember, an overheated engine, especially with GDI, means you're probably going to need new fuel injectors. They're often going to be damaged when the engine overheats, because remember, these are directly in the cylinder themselves. So in this case, if we're already sending the head off to be resurfaced, we're putting a new head gasket in, probably lapping the valves or maybe even replacing the valves, there's really no additional labor to put new injectors in. It's really just the cost of the part. So it's always a good idea if you're talking to someone who's working with a GDI system where you've had an overheated engine or a head gasket blowout or something like that. If they're already taking it apart, it's always a good idea to go ahead and replace the injectors on that head before you put it all back together. Again, there's no more labor involved. It's just a matter of the cost of parts. So if we can get the customer to commit, it's always a good idea. And so with that, I'm actually going to pass it over to Mr. Aaron Schaefer, who's going to talk to you about some, I think, really important factors when it comes to what injector you use, why you use that injector, and how important it is for the longevity of the vehicle and the engine. So Aaron, it's yours. Take it away.
Awesome. Yeah, thank you. Thank you very much, Corey. The About 8 weeks ago, I had the opportunity to travel to Greenville, South Carolina, where we have a fuel injection manufacturing and testing facility. And the purpose was we wanted to follow around our engineer down there as he tested multiple fuel injectors. And we did a couple of tests. The first thing he tested for was spray pattern. And this is really the cone shape of fuel mist that is going to come out of the injector. These are specified by the OE. The number of degrees can change based on the application and the size of the cylinder, the size of the intake manifold. But whenever you're developing an aftermarket fuel injection, one of the things you want to look for is make sure you engineer a part that matches the OE spray pattern in terms of fuel mist and the angle that it's going to come down on. So we tested OE first, and this particular application was correct. It tested at 20 degrees. The next thing we did was tested ours, and that was also 20 degrees. So good job by the engineering team getting that to match. We also tested two other lower cost injectors, and there was some variance in here. The first one was too narrow, and this isn't good, but it's not terrible. It was a little narrow, and that really means that the fuel atomization isn't going to be as efficient as it could be. Generally, what happens is it's going to need a little bit more fuel dumped into that cylinder for combustion. Um, it's a small amount. It probably won't cause damage, but it certainly doesn't allow the engine to run as efficient as it's capable of. What we saw from another low cost unit was much more damaging, and this was a spray pattern that was 14 degrees too wide. It's a pretty big percentage when you want to be at 20 degrees. And this was wide enough that if this was installed on a vehicle, and even though it's a multi-port injector, so it's going to be far enough up, but it's so wide that you would start to see fuel running down the cylinder wall once when that intake valve opens. And that, as Corey explained earlier, that can cause big damage when you're dumping fuel down the cylinder wall there. It's just going to wash away the oil, and you can damage the wall and damage the rings. So, the precision engineering that goes into a specific injector is very critical. The funny thing, you put on a vehicle, it's going to work, right? The vehicle's going to run, probably won't even trigger a check engine light. Um, and that's the real danger in these parts. The other thing we tested for was dynamic flow rate. And this is how much fuel an injector will flow over a specific period of time. So all of these were done at 90 seconds. The first thing we did was tested OE, then we put ours on the machine. And again, both OE and ours were very consistent, which is what you want to see. And they were the same, right? We were able to match OE design spec for flow rate. There was two problems that we saw with the low cost unit, the first low cost unit. The one was they were just inconsistent. Two of them were reasonably close. One of them was overfueling significantly more, about 12% more than the other ones. So this is going to cause a problem. And as Corey explained earlier, for where the O2 sensor is, becomes very difficult for the ECU to be able to effectively adjust for this. Uh, the other issue is that they were all overfueling. So, what we would suspect is that the ports in here, the end of the metering discs, the holes were probably larger than what they could have been or should have been for this particular application. The other low cost unit, the good news is it was more consistent, but the bad news is that these were significantly underfueling. So in this case, we suspect that the metering holes were something was too small. Whether it is the actual inlet tube itself or the metering holes, but something was limiting the amount of fuel that should have been going through the injector. And when you are limiting the amount of fuel, you can eventually have a lean condition. The ECU can only adjust so much, but if the injector is only capable of delivering so much fuel to the cylinder, it could cause catastrophic engine damage. So there are some real risks with some of these low cost, low quality injectors. Now, I mentioned metering discs, and I just want to put this slide up so you can get your mind's eye around what these actually are. At the very tip of an injector, you'll see one of these discs, and it's going to have a series of holes in some type of pattern. And these are application specific. The size, the angle of the hole, the angle that it's cut, how it's indexed onto the end of the injector are hyper critical to correct performance on the vehicle. This is why we machine and use lasers to cut our own metering discs in our own manufacturing facility in South Carolina, so we can control that entire process, as well as end of line test the injectors to make sure that the flow rate and the spray pattern is exactly what it needs to be for that particular application. We'll shift gears a little bit and talk about some other injectors that are out there on the market. And I think the more you start to understand about how this whole system works, and drawing analogies to ignition coils, and which I think is a really good thing, because of course these work in concert with an ignition coil for combustion. Um, these are some very similar parts. They have a coil winding. It uses electromagnetic pulsations. They're electrical components that just have a pretty simple inlet tube running through the middle of it and a metering disc at the end of it. Yeah, but there's no remanufactured ignition coils out there, because when there's a failure on an electrical issue, that's it. Well, that's largely where we are with fuel injectors. It's a pretty simple inlet housing that's a few different components that are first welded together, and then the coil windings are wrapped around it, and then it's sealed inside of a plastic overmold. So it's difficult to understand how anyone could actually truly remanufacture an injector without replacing everything, right? So an injector, the way I look at it is it's either all new, or it has just been cleaned, flushed, and had new seals put on it. What people are getting with reman injectors are injectors that have old original electronic components that have been through thousands and thousands of heat cycles. And I guess what we've seen from testing them is they generally test pretty well in terms of flow rates and spray pattern, and that's because they're OE injectors, right? So the metering discs are correct. They've been cleaned, so they do generally work okay. But the big downside is for how long, right? The injector could be, it could already have 200,000 miles on it. So that's the real risk we see with reman injectors. And we'll talk, a little bit about what you get, or what you're out there and able to go to the market with the standard program. As a company, we have 15 of our own R&D centers around the world, and we are a manufacturer. We're an expert manufacturer with 21 of our own manufacturing facilities, including Greenville. which I know isn't too far from where some of you folks are, probably a couple hours south. That's where we manufacture and test, engineer our fuel injectors. We also do a lot of on-vehicle testing at our testing center in Texas, where Corey is. And we certainly try our best to support you folks out there in the street with the appropriate literature, marketing materials, videos, and even category management assistance to help make sure the stores have the correct injectors and the correct related parts on the shelves. And we know there's some choices that are out there. Your customers have choices, but really what it comes down to is that generally in the aftermarket, folks are making a decision between a low cost Asian source injector. They're very cheap, but they have very limited quality control and testing and hyper inconsistent performance. And because of how an O2 sensor is going to read, when these are inconsistent, it's going to adjust as best it can. The ECU will, but the vehicle, again, the check engine light may or may not come on, but the vehicle certainly won't be running as well as it's capable of. Then you have the reman injectors that'll work okay for some length of time. And then you have a complete program with 100% all new, never remanufactured injectors that are tested. And the other thing that we're able to do that we're pretty proud of is be able to provide you with a complete program with full line coverage on the injectors, as well as the related components that are often needed for a complete and correct fuel system service. So with that, I'll turn it over to Aris.
Thank you, Aaron and Corey, for those tech tips and explanation of the gas fuel injection system. Now let's talk about what we offer on this program. So this slide is your quick reference menu to one of the most complete fuel injection programs in the industry. What you see in here is not just a list of parts. This program will help you capture more sales and ensure complete confident repairs. We start with our 100% new injectors covering all major types, like over 750 SKUs in M5 injectors, and we also cover TVI injectors and new technology leader GDI injectors. Each of them is engineered to meet OE performance and backed by in-house manufacturing and testing expertise. But we don't stop on injectors. We also offer the related components from fuel feed lines, pressure sensors, to dampers, regulators, and service kits. These parts aren't optional. They are essential. So if you're not offering them, you're risking an incomplete job and leaving money on the table. And that's where standard comes in. We've done the hard work for assembling this program so you don't have to. With industry-leading coverage, OE matching quality, and a full range of support parts, we're proud to be your one-stop shop for gas fuel injection. And when it comes to delivering a complete solution, standard leads to, and the rest follows. So in this chart shows just how much injector technology has evolved and how far we've come as an industry. In the 1980s, TVI dominated, and then by the mid-90s, MF5 injectors became the standard. And today we're seeing a major shift toward the GDI, or like Corey said, the dual injector system, where they use GDI and MF5 injectors. And of course, standard has stayed ahead of the curve throughout it all. We now offer over 990 new fuel injectors, covering more than 98% of the US BIO. And that's over 272 million vehicles. Wow, that's 272 million opportunities. So no matter what era of fuel delivery your customers are working, whether it's TVI, MF5, or GDI, you can count on standard to deliver the parts, coverage, and quality to get the job done. One program, all technologies, complete confidence. As you can see on this slide, clearly shows where Standard stands in the market. At the top, when it comes to both new MF5 and new GDI injectors coverage. On the left, you'll see our new MF5 injector competitor landscape with 762 SKUs, and that is including our MF5 multipacks. Standard outspace every other suppliers, including reman programs. That means better coverage, more first call opportunities, and fewer lost sales and returns. And the GDI side is the same story. We lead with 193 new GDI injectors, and we are continuing to expand as this is a growing technology. Unlike many others, who relies on reman options, we offer new injectors that are OE matching that the installer can trust just out of the box. When your customer need fuel injection, whether it's the legacy of MFI or the latest GDI, Standard give you the best coverage, highest quality, and the confidence to deliver the complete solution. So a great upsell opportunity is our MFI multi-pack. This should always be offered when a customer is looking for one injector. And an important point to make when selling or installing one injector is that imagine all the injectors, or think about this, all the injectors are the same age, right? Or maybe they're not. Who knows when was the last time they were all changed together, or if they were. But do you think that all the injectors will last a long time if you change one, or do you think the older worn-out injector will work as well as the new ones that the customer is purchasing? So when a customer walks in or call for one injector, there's a good chance that the others are just worn. Offering a full set not only improves vehicle performance, but also reduces labor time and comebacks. With 22 kits available covering over 36 million vehicles, these packs are ideal for popular platforms like GM trucks and SUVs, and they are high volume and high demands. Plus fewer box to stock, fewer part numbers to look up. It's a cleaner solution for your shelf and your customer. So multi-packs make the sale easier, the repair cleaner, and your customer happier. And that's a win across the board. Now, not only do we have the industry-leading injector coverage today, but also committed to offering the most comprehensive aftermarket program for years to come. What you see here is an example of the MFI injectors that are gaining momentum. We want to share the real-time market so you can be better prepared for the next wave of demand. This category, especially among domestic applications like Chrysler, Dodge, Jeep, Ram, and Ford, is seeing an increased replacement activity. High BIO parts like FJ 1431 with 3.5 million vehicles in operation and FJ 1520 with over 800,000 of BIO coverage representing growing sales opportunities. We recommend reviewing inventory now and planning proactively because part numbers are positioned to become top sellers, and we want you ready before the demand spikes. With Standard, you're not just stocking for today, you're ready for tomorrow. Now, with the, like I said, for MF5, the GDI is a fast growing opportunity in the aftermarket, and we, of course, got you covered. This slide highlights a few GDI injectors that are quickly gaining momentum. And thanks to the growing repair demand and high VIO coverage, this is an example of a span of both import and domestic brands, including high volume platforms from Hyundai, Honda, and Ford vehicles. Parts like FJ 1438 and FJ 1489 each cover over 1.6 million BIO, making them a smart addition for your stocking ahead of the rise in demand. And as the GDI system age, vehicles hit higher mileage, and of course, injectors failures are becoming more common. So this is the category that you want to watch very closely. And with standard, you're not only reacting, you're staying ready. Be first in the market, first to shelf, and first to be the call for your customer. Now, gasoline direct injection program system are very complex, and the repair goes beyond just replacing the injector. And then tell me about it, because I had an experience with a vehicle that I had a Honda Pilot with a GDI high pressure pump that, me trying to save money, for a few days I was, putting gasoline that it was not the one that it was demanding, and the repair cost me a lot of money because not only the injectors they had to change because it had to be at the dealer at the time. It was a brand new Pilot 2020, and 2017, and they had to change the whole fuel injector system because the gasoline had water in the tank, and then it affect the whole GDI system. So standard of offers the complete job for situations like I had, from high pressure fuel pumps and fuel fill lines to crankshaft followers, seal sensors, and even a complete service kit. Standard give you the courage to tackle the entire job. Our commitment to provide industry-leading aftermarket supports doesn't stop at injectors. We back it up with a full range of related components: fuel pumps, fuel lines, sensor gaskets, and more, because that's what it means to be a true one-stop shop. When you start the full GDI program, you're not just selling the part, you're solving the real problem for your customers. And that's exactly what makes Standard the choice for the complete GDI system service. And I'm not sure if you knew, but a pro tip is, did you know that high pressure fuel lines with yellow tags should never be reused? These are designed for a single use only, like Corey mentioned earlier. Reinstalling them can lead to leaks, performance issues, and potential safety risk. And we all know how popular the GDI systems are in today's vehicles, and the demand is only growing. So if you want to be in the GDI business, these are the parts that you need to stock. This slide here highlights essential GDI components, including some of our top selling part numbers like GDP 105. That's a high pressure fuel pump for GM and trucks and SUVs. And you know how popular GMs are here in the US. Also, we stock GDL 103 and GDL 109. That's a high pressure fuel line for GM vehicles. And SK 106, that's an injector seal kit for Audi and Volkswagen vehicles. So these parts aren't optional. They are part of the complete job to prevent comebacks and returns of one fuel pump or injector that they might assume is defective, but it's actually more along the whole system. So we are here to provide the repair experience by offering a complete solution from the first part to the last bolt. When you stock these parts, you're not just meeting demand. You are positioning yourself as a true GDI ready partner and helping your customers to get the job done right the first time. This one is the most exciting addition to our fuel injector program for the first GDI pressure fuel pump kit available in the aftermarket, guys. So even after scanning the vehicle, like Aaron mentioned earlier, it is incredibly difficult to know if the issue is the high pressure pump or a wrong crankshaft follower. And that's why these kits include both. So the shop can replace everything at once and confidently know the problem is solved. This innovation didn't go unnoticed. We received a prestigious new product award at the Apex in 2023 for these kits. And right now we're currently offering 7 SKUs covering high volume applications from Hyundai to 4. And we are already identifying more coverage coming in 2025 since, Aaron and Corey mentioned earlier, this is a high demand and up and coming system in the fuel injection lines. So the bottom line, no other supplier offers this level of diagnostic support and OE style completeness in a single box. This is a perfect example of how we are helping shops save time, reduce comebacks, and get the job done right. So let's wrap up by talking about what truly sets standards apart. Our commitment to quality backed by rigorous testing. At this point in the sale, your recommendation matters the most. Customers trust what you trust. And this slide is about giving you the confidence. All standard MF5 and GDI injectors are 100% new and tested. Every part undergoes initial life cycle validation and end-of-line testing before reaching the shelf. In fact, our process includes more than 35 different tests and inspections covering everything from endurance and spray pattern, like Aaron said earlier, to thermal cycles, vibration, and flow calibration. But we don't stop at the lab. We also run a vehicle test in our at our Texas testing center to validate performance in real world conditions. Maybe Corey, I'm not sure if you guys have seen some of the videos, but we have done testings that Corey and Ryan have posted in our website. So make sure you scan the QR code to find more information regarding our testings and information about the system. And whether you're recommending ignition components or fuel delivery parts, you can be sure that every standard product is engineered and tested to meet OE performance. We made investments to build trust with you and your customers. So when you see a standard box, you can rest assured that it is quality designed, quality built, and quality tested every time. Well, now I'm going to stop talking and go back with Aaron with more about self-support.
Yeah, thank you. Thank you very much. So we've given you a lot of information this morning, and I think the important step now is to be able to prepare you to talk about this to your service provider customers and support you. So there's several different things that we've created to help you tell this story to your customers. We have a lot of different printed materials, including a 6-page program brochure that describes the complete fuel injection program. We create new item spotlights once a year, and these feature the up and coming numbers that Aris showed. So those are available to you through, we don't put them on the website, but they're available to you through your standard rep. We do want to make sure you have these numbers on the shelves in the stores because they're not new. But they're stuff that we're starting to see sales on quickly, and there's going to be very good opportunity on these numbers in the coming years. We also have a lot of different single page sell sheets you can go out to the street with as part of our What's in Your Box campaign. And we also recently reduced a Just the Facts flyer that explains why the idea of remanufactured injectors is largely a myth. On our YouTube channel, you'll find 725 different videos, including 2 different playlists for gas fuel injection. So check that out. That's a nice resource that you can use at the store level and when you're on the street. And then for a little bit more detailed information on gas fuel injectors, we have a digital product portfolio that resides on our site under the digital resource section. It's over 20 pages of in-depth technical data, technical tips, information on the training classes that are available to your service provider customers and technicians. It's kind of the end-all be-all resource for gas fuel injection. And I spoke a little bit about the YouTube channel, but this is a newer video that we released a few weeks ago rather, with Corey. It already has 29,000 views on YouTube. Corey did a great job with this. It's featured on our YouTube channel right now. it's kind of a 3-minute version of what we just went through today. So, if you have some colleagues that weren't able to attend this and you found some value in it, just go to YouTube, show them this 3-minute video, and it'll get them close. And then, lastly, we can just wrap it up and want to make sure we're clear about what's in the program. The fact that ours are entirely new, never reman, that we build our own gas fuel injectors in Greenville, South Carolina. They're tested and engineered to match OE spray pattern for correct and optimal on-vehicle performance. They're tested in the lab, they're tested on vehicles. But it's really the related parts in the complete program that start to set us apart from other folks, especially the folks on the OE side of the business. Because I think we'll admit that most OE injectors are good, but what they're not able to bring to market with are complete programs and the related parts that we're able to design and bring to market. And then we try to support you guys as best we can in the field, so you can tell the story and you're prepared, and you can confidently talk about this program to your customers. So that's what we've got. Thanks a lot for tuning in, and we will talk to you soon.
Hey, thanks, Aaron, and thank you, Aris, as well. I think that's a lot of great information. And again, I started out by saying hopefully this will open up the door for conversations that you haven't been able to have. I think just what Aaron covered with the spray patterns and flow rates, and what Aris covered when it comes to coverage and availability, what the full program looks like. Those talking points alone are enough to really get some engagement with people when it comes to talking about gas fuel injection. So my hope is that after we close the call here in a few seconds, you'll have someone call about some either GDI injectors or multi-port injectors, and you'll know exactly which ones to recommend. And when they ask why, you'll have the answer. So with that, I'll thank everyone again for being here. Thank you for taking time out of your day, and hopefully we'll see you next month when we talk about evap emissions. Have a good one, everybody. We'll see you next month.